So let's look at some data. So the question is, how do we calculate the relative atomic mass from a mass spectrum? So this is something you might see um, if you were using a mass spectrometer. You would get this graph, which has the percent abundance, and then the mass to charge ratio down here. And in this case, it's just showing you for boron. This is boron 10 and boron 11, right? And for boron 10, 20% of the sample was that, and for boron 11, 80% of the sample was that. So I want you to think about, using what we know and what we learned last week, how you could calculate the relative atomic mass for boron. Take a second and write that down. Okay, so we're using the math that we already know, right? We know that we can multiply isotopes by their percentages, right? And then we can add those together and divide by 100, and we can get the average, the weighted average of these two. Right, so this is exactly what we did last week. 20% of the sample is boron 10, so we're multiplying those together. 80% of the sample is boron 11, and multiply those together. Divide by 100, and we get 10.8 for the relative atomic mass. So let's do another one. Calculate the relative atomic mass of magnesium to 3 significant figures. And I know we haven't specifically talked about this yet, but this just means 3 digits, right? So your answer should round to 3 digits. We'll talk about this eventually. So here's your relative abundance, right? This is for magnesium. We have magnesium 24, 25, and 26. We have abundances of 79%, 10%, and 11. So take a second and calculate that. Okay, so same math, right? Just another practice problem. 79% times 24, that's magnesium 24, plus 10% times magnesium 25, plus 11% times magnesium 26, divided by 100, we get 24.3 as the relative atomic mass of magnesium. So let's move on to something a little bit more difficult. So I want you to calculate, or I guess convert the relative abundances now to percent abundances. We have this graph over here. This is for neon, so we have neon 20, neon 21, and neon 22. Do that first, and then calculate the relative atomic mass of neon to 2 decimal places. So see if you can figure this out. This one you should know how to do at this point. So using our data over here, this one's a little trickier because these are not in percentages already, right? So your total amount is not 100 in this case. It is these numbers all added up together. So 108.3 is your total. So that's what you should be dividing by instead of 100 now to convert these. So we would take 100 divided by 108.3 times 100 to give us a percentage. This is how we get the percentage. We need this times 100. So that means that neon 20 is 92.34%. Neon 21 is 0.23%, and neon 22 is 7.38%. So you needed to do this first, right? Because we need these percentages. Then we can use those to calculate our relative atomic mass. So plug all those into our formula, and you will get 20.14. Right? So if you ever see a graph like this that doesn't have percentages, it has relative abundances instead, right? You can convert them by making sure you know what your total sample is, dividing each individual one by that, and then multiplying by 100 to get that. So let's think about this. Suggest what each peak represents in this mass spectrum of Cl2, chlorine 2. Uh, so yeah, we have relative intensity, we have the mass to charge ratio, right? And this is for elemental chlorine, which is two chlorines bonded to each other. And we have these 5 different peaks, right? We have 5 different peaks for Cl2. What do you think each of these peaks means? So take a second to think about that. Write down your answers in your notebook, and then I will talk about it. Okay, so we've already seen before that chlorine has 2 common isotopes. That is chlorine 35, right, and chlorine 37. These 2 peaks are kind of easy to figure out, right? In the mass spectrometer, this is chlorine 35, and this is chlorine 37, and 35 is more abundant than 37. But what we put into the spectrometer is Cl2. So what's happening is some of those Cl's are breaking apart to form these singular Cl's, which we see, but most of them are staying together, which means their masses will be added together. So there's 3 possible ways that could happen, right? It could be Cl35 plus Cl35, which would give you Cl270, right? This is the first mass of Cl2. It's the most abundant because this is the most abundant isotope. Then you could get 35 plus 37, right? That would be this peak. And you could also get 37 plus 37. That would be our smallest peak because the 37 isotope is the least abundant. So that is 1.2. You did it. Good job. Now I want you to create another concept map, just like you did for 1.1. We're going to continue to make these as we get through these sections. Eventually we'll have a bunch, and we will start to link them all together, and it will be super helpful when we start to think about and study for the IB exam, because there are lots and lots and lots of things we cover in this course. So we need to be able to connect the dots between all of the things. So here are your concepts over here, and some core concepts, right, that we've been learning. Our guiding question was, how do the nuclei of atoms differ? So think about that. Maybe that can be at the center or at the top of your concept map. That is your first piece, or your first assignment. Something I want you to include either on your map or perhaps on the back or something. Define these terms, right? So we have 8 terms: nucleus, nucleon, atom, ion, isotope, percent abundance, relative atomic mass, and mass spectrum. So find definitions for these, write them in your own words. You could probably pull them from your notes. And then the last thing, I have another Quizlet for you to practice the things we've been learning. I also have good news unrelated to this specific thing, but I will be there next week. So next week we'll move on. We'll keep moving on, but we are going to have a test at some point soon. So I will, once I get there, I hope you start to study for that. But all of these review things that we're doing will be helpful study tools as that approaches. So to review, what you need to do, right? Create this concept map, define these terms, and then when you're done with all that, use the Quizlet to help you review and study what we've learned so far. All right, have a great day. See you next week.